Unit 10 is all about modeling. We're going to start Unit 10 by talking about how to model something that you have actually been seeing for a long time in your life. We're going to talk about how to model patterns. If we notice a pattern, could we translate that mathematically and come up with a rule so that we could find a certain term in that pattern? What is a pattern? How do we tell what the pattern is? That's what we're going to focus on in the first part of Unit 10. And then in the second part of Unit 10, we're going to focus even further on different types of models. What are the main different types of models that you might see used in the business world, that you might see used in real life situations? How do we model those with equations? What do those equations look like? We're going to talk about exponential growth and money in bank accounts, and we're going to talk about decay like half-life, which ties to science. We're going to talk about compound interest and all kinds of different things that are really going to apply to different scenarios, and I think you're going to see how they come into play. The nice thing about this unit is that really it's a lot of formulas and plugging in values and making sure you know how to use what's there. You don't have to have really any prior knowledge to previous units that we have covered in order to be successful in this unit, and I think that's a really exciting thing. So today we're going to jump right into an arithmetic sequence. We're going to talk about what it is and what's special about it. So 10.1, an arithmetic sequence. And our essential question, what is an arithmetic sequence and how do we write it mathematically? A sequence is just a list of numbers that form a pattern. A sequence is just a list of numbers that form a pattern. Each individual number is called a term. So we have a first term, a second term, a third term. In a sequence, we use some math notation that I want to make sure you understand. We use the letter A to represent the term, and we use a little subscript of n to talk about the number that the place that is in the sequence. So for example, we would say that A sub 1 is the first term in the sequence. And actually, let's just write a sequence so you can kind of see this here. Let's just write 1, 2, 3, 4, 5, 6. So A sub 1 would be the first term, which in this sequence that we just wrote, the first term is 1. A sub 6 would mean we're talking about the sixth term in the sequence, which would be the term that is in the sixth spot. A sub n would refer to the nth term, meaning the term when we plug in the number n, or the term in the nth spot when we're looking at our pattern. That's just a sequence in general. Now we're going to talk about, for the rest of this section, a very specific type of sequence, and that's called an arithmetic sequence. An arithmetic sequence is a sequence where the pattern is that you are adding or subtracting the same number over and over and over again. And that number we refer to as D, and we call it the common difference. So this pattern that we just actually have up here, this is an example of an arithmetic sequence. This is arithmetic, because the pattern is that we are just adding 1. Every time to get to the next term, we add 1. As long as that number is the same, we can say that that number is our D value and that the pattern is arithmetic. So let's just look at a couple examples, make sure we understand this vocabulary. How do we find out if a pattern is arithmetic? So looking at this first example here, number 1, I want you to just quickly look at that and figure out what do we do to 9 to get 13? What do we do to 13 to get 17? From 17 to get 21? Go ahead and pause the video and ask yourself, how are we moving from one term to the next? Okay, hopefully you had time to look at that. And to get from 9 to 13, we're adding 4. To get from 13 to 17, we're adding 4. To get from 17 to 21, we're adding 4. All of these are the same, which means this is an arithmetic sequence. And that common difference is not 3, silly. That common difference is 4, that number that's being added over and over and over again. And then we're actually asked to find the next 3 terms. So if I added 4, I would get 25. If I add 4 to 25, I would get 29. If I add 4 to 29, I would get 33. And the pattern would continue. So let's look at number 2. Pause the video, identify what that pattern is, and then unpause the video and see how you did. So I'm asking myself, how do I get from 10 to 8? I subtract 2. How do I get from 8 to 5? I subtract 3. How do I get from 5 to 1? I subtract 4. So there definitely is a pattern here. I think if I asked you what would we do to find the next term, you would be able to say we would subtract 5 to find the next term. Now, all of these numbers that are being subtracted are not the same. So this is a pattern. We could find the next 3 terms, and we will, but this is not arithmetic because there is not a common difference. The number that is being subtracted each time is changing. So we would say this is not arithmetic. And this I would get -4. If I subtracted 6 from -4, I would get -10. If I subtracted 7 from -10, I would get -17. So we could still find the next 3 terms. We just can't call this an arithmetic sequence because it's not. All right, I want you to pause the video and work through number 3. Remember that even though they're fractions, and I know fractions are a little bit scary, they already have a common denominator. So figure out what's happening to get from one numerator to the next. So hopefully you paused the video and had time to work through that. To get from one term to the next, we're adding 2 in the numerator, which means that we're adding 2 over 4. Each time we're adding 2 over 4, so those are the same. So this is, number 3 is arithmetic. The common difference is 2 over 4, which I'm going to simplify here. However, when I'm finding the next terms, I'm not going to simplify it. If I'm adding 2 over 4 to 3 over 4, that would give me, I'm going to come up here because I'm out of space, 5 over 4, and then 7 over 4, and add 2 more, 9 over 4 would be my next 3 terms. So hopefully now you're starting to feel like looking at a pattern, you could identify what that common difference is in order to say if it's arithmetic or not. Now we're going to move into the next part of this section, which focuses around how do we write a mathematical rule for what we're saying in words. So what we just said in words, for example, on number 1, was that the pattern is that we add 4. Well, is there a mathematical way to say add 4 using math notation instead of using words? That's what we're going to focus on next. So there's 2 types of rules that we're going to learn about for sequences. One is called the recursive rule, and the other is called the explicit rule. And we'll talk about the explicit rule and why the explicit rule is important in just a couple of minutes. But right now, let's focus on the recursive rule first. What is a recursive rule? So the recursive rule uses what we already know about one term to get to the next term. So the recursive rule will say, and I'm going to write in words what is being said here in math notation. A sub n means the new term, or the nth term, is equal to, is a sub n minus 1. This means the term right before, plus d, which is our common difference. So think about what this is saying. This is saying to get the next term, a sub n, take the term right before it, a sub n minus 1, plus the common difference. To take the term before it and add whatever that common difference is, or subtract whatever that common difference is. So when you are writing a recursive rule, and I'm going to put a box around this because this is something you're going to use every time you write a recursive rule. The only thing you're substituting in when you're writing a recursive rule is what this d value is. Everything else stays the same, and you're going to need to use subscripts, those little numbers that go below when you are writing this. So let's go ahead and look at this example for A. Write the recursive rule, 3, 5, 7, 9. So I know, whoops, I don't want to be in highlighter mode. I know that when I'm writing a recursive rule, I'm going to have a sub n equals a sub n minus 1, and then I'm going to have my common difference. So let's go ahead and identify what's going on in this pattern. 3 to 5, I'm adding 2. 5 to 7, I'm adding 2. 7 to 9, I'm adding 2. So this is arithmetic, which means I'm allowed to do what we're about to do. And that common difference is 2, so I'm going to put plus 2. Now, just to kind of hit home and make sure we actually understand what this is saying, what if I asked you to find the fifth term? Let's plug in, let's use n equals 5 in our recursive rule to see what that means. So a sub 5 will equal a sub 5 minus 1 plus 2. Okay, this still seems a little bit confusing. Let's take it a step further. A sub 5 equals a sub 4 plus 2. But what was a sub 4? A sub 4 is the 1, 2, 3, 4th term, which is 9. So a sub 5 is 9 plus 2, which is going to give us 11. So I can say that the fifth term is 11. That's what this notation means. And notice I'm not just writing 11, I'm writing a sub 5 equals 11 because there's an infinite number of terms in this sequence, but we're just being asked for the fifth term. And how do we find the fifth term? We take the fourth term and we add our common difference, which is 2. So let's go ahead and look at 4, 5, and 6, and there's a bunch of things being asked here, but we're just going to look at right now the recursive rule. So I'm going to just in purple kind of put a little box around recursive. We are just going to look at the recursive rule. So for each recursive rule, we're going to have a sub n equals a sub n minus 1. So I'm actually going to go ahead and I'm going to write that on each problem because that is the beginning of my rule. Make sure your subscripts look like subscripts, like they go below, not at the same level. I should not see, this says a times n minus 1. That's totally different than what is right here. So just make sure that they do in fact look like subscripts. All right, looking at number 4, go ahead and pause the video and identify that common difference. How do we get from one term to the next term in this pattern? Go ahead and identify that common difference. That common difference should be 4. We're adding 4. So our recursive rule is a sub n equals a sub n minus 1 plus 4. That is the rule. On number 5, we're actually being given not the rule written out as we've seen it before with a bunch of numbers separated by commas, but they're actually telling us, hey, guess what? D is 1.4, which means we can simply, let's make that look a little nicer, put a sub n equals a sub n minus 1 plus 1.4. And that is our recursive rule. Why don't you go ahead and pause the video and figure out what number is going to go in that last spot on number 6. Hopefully you noticed that this pattern was subtracting 6, so a sub n equals a sub n minus 1 minus 6. So to recap what we just did, we just created a rule that tells you how to find the next term given the term before. Now something I want you to notice, if we looked at any of these patterns and I asked you to find the 50th term, based on the rule, you would need to know the 49th term, right? Based on the recursive rule, if I asked you for the 50th term, you would need the term right before that, which would be the 49th term. And that is a little bit limiting. So this is limiting because we have to know the term that comes before the term that we want. So if I asked you to find the 100th term, you wouldn't be able to do that without knowing the 99th term, and you wouldn't know the 99th term without knowing the 98th term. And that feels like a whole lot of work to go one by one by one by one to get to some specific term number. Wouldn't it be better if there was a way where if I wanted the 100th term, I could just plug 100 in, and then that would tell me the 100th term. That seems like it would be a much more efficient and a much better way to find a specific term. And that leads us to the idea of an explicit rule. So explicit rules allow us to find a particular term by simply plugging in that value, plugging in the number. So if I wanted the 100th term, I would plug in 100 for my n value. So what we need to do is we need to figure out what does that look like and how do we actually write an explicit rule for an arithmetic sequence. Remember, everything we're doing today is for patterns where we are adding or subtracting the same number to get from one term to the next. So again, the explicit rule describes how to find a term given the term that we're looking for. And here is how the explicit rule looks written out. A sub n is equal to a sub 1. Remember, a sub 1 is the first term. That subscript tells you what term number we're talking about. Times n minus 1 times d, and d is that common difference, what you're adding each time. Now, a couple of things. We talked about with a recursive rule that the only thing that you have to do is plug in D, and that's not the same with the explicit rule. You need to plug in D, and you need to plug in A plus 1. So notice plug in values for D and A plus 1. And here's the really big thing. Then you need to distribute, combine like terms, and write in standard form. So what I mean by that is once you've plugged in A sub 1 and D, you're actually going to distribute this D value, and then you're going to combine like terms. So your final answer should look like A sub n equals some number times n plus some other number. And that's a little bit different. So there's a little more work to get this rule, but this rule is so much more useful than the recursive rule. So let's look at the pattern that we had looked at before, 3, 5, 7, 9. We had looked at that in the box up top where we looked at arithmetic sequences and recursive rules. And we had said that that common difference was 2. So now we're also going to identify the first term. The first term in this case is 3. So let's look at our rule. A sub n, I'm going to just rewrite the rule, is A sub 1 plus n minus 1 times D. And then let's go ahead and plug in A sub 1 and plug in D. So A sub n is going to equal our first term, which is 3, plus n minus 1. We're not plugging anything in for n because our goal is to have an equation that still has an n in it at the very end, so that I could say if I want the 100th term, we're going to plug in 100 for n. If I want the 12th term, I'm going to plug in 12 for n. So in this rule, we should still have an n. The last thing we need to do is plug in our common difference, which is 2. So we're most of the way there. Now, what we need to do is distribute this 2. So this is going to give me A sub n equals 3 plus 2 times n is 2n. 2 times negative 1 is negative 2. And then we're going to combine like terms. And when it says write in standard form, that means your n number should come first. So 2n, and then if I combine my 3 and my negative 2, I get plus 1. So let's recap what we did. We plugged in A sub 1, the first term, and we plugged in D, the common difference. We plugged that into this formula in the box, A sub n equals A sub 1 plus n minus 1 times D. Then we distributed our difference. We multiplied 2 times n and times negative 1, and we combined like terms and made sure that we wrote our n value or our n term first. Now let's check and make sure our rule works. The first term is 3. So if I plug in 1, when n equals 1, I should get 3. Is that true? 2 times 1 is 2 plus 1 is 3. Yep. Let's see. If I plug in 2, according to this, I should get 5. Does that work? 2 times 2 is 4 plus 1 is 5. So our rule is working. And it's nice to be able to check and make sure. Now part B is going to ask us, use the explicit rule to find the 100th term. If you remember moments ago when I said we were looking at the recursive rule, in order to find the 100th term, we'd have to know the 99th term and the 98th term. Now what we're saying is you can actually just plug in 100 for n into the rule that we found. So I'm going to rewrite the rule over here. This means that A sub 100 equals 2 times 100 plus 1. And you can do this math in your head. 200 plus 1 is 201. So we can say that A sub 100 is 201. Okay, let's look at some examples. We're going to do the explicit rule 3 times on the problems that we just did above. So I'm going to put explicit. We're going to do these 3 explicit rules, and then we'll go back and find the specified term for each particular question. Okay. So I'm going to start, and remember there's a little bit more work that's going to be shown on these problems. I'm going to start with A sub n, and I'm going to just rewrite this rule just once up here, n minus 1 times D. So we already identified what D is, right? We said that D is 4, and I'm going to point out on I'm going to point out what the first term is. The first term, A sub 1 is, okay, that is really hard to read. Let's try again. A sub 1 is 4 and D is 4. So A sub n is our first term, which is 4, plus n minus 1 times that common difference, and that common difference in this case is 4. Now we need to distribute, so a sub n equals 4 plus 4 times n is 4n, 4 times negative 1 is 4. And now we're going to combine like terms. This is going to give me a sub n equals 4n. Since if I add 4 and negative 4, I get 0. So this is my rule. A sub n equals 4n. So right now, if I asked you for the 100th term, you could tell me the 100th term is 4 times 100, which is 400. If I asked you for the 1,000,000th term, you could tell me that the 1,000,000th term is 4 times 1,000,000, which would be 4 million. All right, let's look at number 5. Number 5 actually tells us the first term right here, and we already identified that common difference. So we can say that a sub n equals the first term, negative 4.2, plus n minus 1 times our common difference, which is 1.4. We're going to distribute that common difference. A sub n equals negative 4.2 plus 1.4 times n minus 1.4. And then we can combine like terms. Make sure when we write this that we're writing it in standard form. So my 1.4n is going to come first. And if I combine, let's do this here. If I combine negative 4.2 and negative 1.4, that's going to give me minus 5.6. So here is my rule for number 5. Why don't you go ahead and pause the video and work through number 6 on your own. Okay, here we go. So a sub 1 in this case is 11. I'm just going to make note of that over here. We said the common difference was negative 6. So for our explicit rule, a sub n is going to equal 11 plus n minus 1 times our common difference, which is negative 6. And since my common difference is negative, I'm going to put parentheses around it so that I remember that I'm multiplying, because when I don't put parentheses, it's sort of misleading what I need to do with this negative 6, which I hope we remember is that we need to multiply it. So this is going to give me a sub n equals 11. Negative 6 times n is negative 6n. Negative 6 times negative 1 is positive 6. And then I'm going to combine like terms, and I'm going to write my negative 6n part first. And if I combine 11 and 6, I'm going to get 17. Now remember, the good news about this is that we can actually check on all 3 of these problems and make sure our rule is right. Plug in 1, plug in 2, plug in 3, and see if those terms are the terms that you see in the pattern. The last thing that we're going to be asked to do here is actually find a specific term, and we're going to be asked on each question to find a different term. Now remember, to find a specific term, all we're doing is plugging n equals the number of the term that we're looking for. So, for example, on number 4, if we want the 16th term, which it's telling us we do, we're going to just plug in 16. And 4 times 16 is 64. So we can say that the 16th term, a sub 16, is 64. Similarly, on number 5, we're being asked for the 12th term. So a sub 12 equals 1.4 times 12. Minus 5.6. This one's going to require a little bit more work. I know that 14 times 12 is 168, so decimal place wise, this is going to give me 16.8, and it's okay if you had to write that out and multiply it. Old school multiplication by stacking those numbers, that's totally fine. And then if I do 16.8 minus the 5.6 that was already there, I will get 11.2. So a sub 12 equals 11.2. Yes, you do need to write your answer the way that I'm boxing my answer here. All right, go ahead and pause the video and find the 60th term for number 6. All right, a sub 60 equals negative 6 times 60 plus 17. Which means that a sub 60, 6 times 6 is 36, so this is going to be negative 316 plus 17. And if I subtract here, that's going to give me negative 343. So a sub 60 is negative 343. So to wrap up this lesson, to hit those key points, to make sure that we know what what the answer to our essential question is, an arithmetic sequence is a sequence where the pattern is that you are adding or subtracting the same number to get from one term to the next. The recursive rule is a rule that uses the term before to find the next term. And the basic or the general recursive rule for an arithmetic sequence is that a sub n equals a sub n minus 1 plus d. When you're writing a recursive rule, the only thing you plug in is that d value. The only thing you plug in is that d value. A recursive rule is not incredibly helpful because you have to know the term before, which is why we have the explicit rule. An explicit rule allows us to plug in any number to find that particular term value. So the explicit rule, the general form, is that a sub n equals a sub 1 plus n minus 1 times d. When you are writing an explicit rule, you need to plug in the number for a sub 1 and for d. Then you need to distribute your d value, combine like terms, and rewrite your final answer in standard form, meaning a sub n equals the part with the n plus the other value. So if you have any questions, go ahead and write them down. I look forward to supporting you on this in class. Thanks for listening.